center. Whoa, 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 what was that, man?
Why did it look so slow?
Nice. Build. Hide. There you go. Jump.
You like killed 10 dudes with them.
Build. Build. Okay, Maverick left it.
Hello everybody and welcome to class today. The third day of CS 135, or technically the fourth, but because we have a day 0, which was the syllabus. So how is everybody doing? Audio good? Actually, audio's gonna be good. I gotta bring the microphone close. Now it should be better. Hello. So I was just thinking, actually, not to scare you guys, but like this class is a lot like the, you know how they say like the virus curve. Like it starts out very easy, or I guess this way. It starts out easy, but then it starts going really steep, and it doesn't stop. Like I would say CS 135 is like here, and then it goes to 202, and then to 302, and then I think at 302 it like curves and evens out. So not to scare you guys, but make sure you don't get too relaxed with this pace that we're going, because we are gonna pick up the pace. So anyways, let's go ahead and jump into the iPad for a second. So today we are going to be continuing into C++ data types, arithmetic operators, the assignment operator, and all of these great things that will allow you to do the second and third assignment, basically. Oh, well, part of the third assignment, but the full second assignment. Basically, we're going to learn how to do math using C++. And if you've ever used a calculator before, it's not very different than that. The only big difference is now we're going to kind of throw in algebra in there because it will make things easier. And also, I guess I will talk briefly about the math library because I do believe you use it in assignment 2. Assignment 2 is one of the ones that Dolly made versus me making it. So she's more familiar with it than I am, but I do believe she uses the math library. And so I'll show you how to do that. That's a rather simple concept to use. So if you use a calculator, you kind of use some kind of function calls in a way, because when you press like the tangent key or the sine key, even the little exponent key, those are all sort of tiny little functions that do something to your numbers. So anyways, let's go ahead and put some notes down first, and then from there we can go on to writing code. I think that'll be the best way to do this. Yes. So, okay. So how many we got? I think it says 11 viewers. I don't know how accurate that is. So last time we really didn't take notes. So far I literally just overwrote it. What's this? Oh, this is oh yeah, I see what I did. Huh, interesting. So maybe I should delete one of these. I thought I didn't have this in there, but I guess I did. And I redid it again. Copy pasting it. So that if and when I get these notes posted, you guys have it like organized. So there are no notes for day 2, at least on this. Will you do something similar to assignment 2? Yeah. So how about we reserve the last 20 minutes of class to do something of that style? I'll open up the assignment and like I think they do sine, so we'll do cosine or something. So yeah, we'll go ahead and do that. Wow, you already have extra credit for attendance. Okay, cool. I will keep track of that later. I have to redeem everybody's points first. So cool. Congratulations. I guess I set the setting too low if you got extra credit from like 4 days. So that's not bad. I mean, it's interesting. How long did it take you guys to get that? Like, well, then again, these are 2-hour lectures, so that's technically 8 hours. Actually, no, because we're gonna do Twitch on Monday, so that's 4, like 5 hours per se. Okay, cool. Well, there you go. You guys keep redeeming that. All right. So, let's actually define what data type is. Yeah, because I put the word data type there, but I don't think everybody knows what that actually means, and that's okay. That's what you're here for. So let's see what the data type is. Because I say we're going to talk about data types, but what is a data type? Well, a data type is a set of values along with the set of operations that can be performed. Sorry, I gotta take my watch off to be able to write better on the tablet. I remember that like 10 minutes ago and then I forgot. That can be performed on those values, and I'll explain that in a second. So a data type, let's think about math for a second. A number is as a data type. The natural number set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the operations that you can perform with those values are all the math operations, like multiplication, addition, subtraction, division, even some of the fancy ones like cosine, tangent, exponent, square root. All of these things are operations that you can do on numbers. you can't do operations on letters. You can't do operations on pictures. You could define that as something to do, or at least you can't do those operations. There aren't really any operations you could do on letters in like common English that I could think of. Maybe uppercasing. Uppercasing is an operation. You can uppercase and lowercase letters. However, you can't uppercase and lowercase numbers. That wouldn't make sense, right? You can add numbers. Could you add letters? Actually, I'd say you could. If I say A plus A, you can say AA. Or, however, if you do like A times A, that doesn't really make sense. Like, what does that mean? You have to you have to define what that operation is. And so, ultimately, the operations depend on what you're operating on. With numbers, there's arithmetic stuff. With letters, there's some things like uppercase, lowercase, and like I said, but not much more than that. Maybe adding letters together. Even removing them is kind of like weird. Like, what is A minus A, right? What other things could you have that are not numbers or letters? At least at this point, I don't want to confuse you. But in programming, you will have more than that. But with a normal language, I don't think you do anything else. But I just want you to think that a data type can be a number, can be a letter, and can be all these other things. But it's not just important to define these data types, but also what can you do with them. Okay? And within those data types, C++ gives us a couple to work with. And we can create more. And you will in 202 when you learn about objects and things like that. But for now, we're going to use the built-in data types as they're called. Okay, so built-in data types. Now, these data types are provided by the language, which means the people that created C++ in its inception decided like these are the ones we're going to give them. However, most programming languages kind of stick to the same data types. They don't change it a lot. I'll tell you one where they change, like Python versus C++, but usually it's all about the same. It's kind of how they pick the reserved words. Okay, and by the way, actually talking about reserved words, data type names are reserved words, so you can't create variables with that name, which is very different than Python, where you can create a variable with everything and it just cancels things. So the most obvious one that not obvious, but the one that you've seen before is int. You saw it even though you didn't know, or we didn't put much attention to it, and I kind of hand waved, was in the function int main. Int stands for integer. And if you don't remember what an integer is, it's a whole number without decimals. Whole number without decimals. That means an integer can be -10, 0, 1, 2, 5, 1,000, 5,000, 9,000, 9,001, -25, -1 million. All of these are integers. Numbers that would not be integers would be like 5.1 or 1.0 or anything that's irrational, like the square root of 2 or pi. These are not integers. It would have to be a whole number. Positive, negative, or 0 is okay. So I guess I'll throw in some examples here in case you're looking at this at a future date. Like that. Okay, and 0. 0 is usually that special case in math, right? So we want to make sure we throw it as an example. Okay, so as you can see, integers are very useful for a lot of things, such as basic math. But they have a limitation. If you're dealing with money, it's much better if you can deal with decimals because of cents, right? You don't have to, because you can just treat all money as cents, and since there's no smaller unit than a cent, then you'd be okay. You can be like, you owe me 5,001 cents. And what does that mean? 5,001 cents, that means they owe you $50.01, So you could do it like that to avoid talking with decimals, but it's not convenient even in normal speak. So if we want to deal with decimals, C++ gives us two other data types, built-in data types, and those are the float and the double data type. Okay, float and double are both going to be numbers with decimals. They don't have to be, by the way, decimals. They actually, I could still have a float be a 5, but that's not their real advantage. Their real advantage is that they can hold decimals. So you could have 3.14 if you want to represent pi. You could have 258.1, you know, 8.9, negative 2.5, or I wrote 2.1, I guess, I don't know. 0.1. You can still have 0, but you just say it's 0.0 per se, and so on. Now, what's the big difference between them if they both can do that? This gets a little bit into upper level 218, 219 tier of classes, but what happens is if you think about what is the value of pi, everybody knows the value of pi is like 3.14 and 1592 or something. It's an irrational number, right? It actually goes on forever. Like it has an infinite number of digits, right? You guys agree with me that there are numbers, like for example, what is the square root of 2? I believe the square root of 2 is also an irrational number, which means that numbers go on forever. There's no, if I ask you, so if I ask you like, give me the square root of 2 exactly, well, the only way you can do it is by putting square root of 2 like that. If you try to give me a decimal representation, it's not going to be accurate. You're going to cut off at some point. Just like when we talk about pi, we usually just say 3.14, right? And so, you know, it's even us trying to remember a number that has a lot of decimals after it is hard because it requires, I guess, more memory space. Well, same thing in a computer. In a computer, you have to store this information if you want to deal with irrational number, and you have to kind of cut it off at some point. At some point, you got to say, okay, I don't want to store a billion numbers after a decimal because it's pointless. I don't need that much accuracy. And so C++ basically said, we're going to give you 2 decimals, and one of them is twice as accurate as the other one. And there's a lot of hand waving involved, but in a simple layman's term, you can think of a float as a 32-bit, and we haven't talked about bits or anything like that, but it's for those of you that know, it's a 32-bit floating point, and double is, as the name implies, double the size of a float. So while it's not exactly like this, you can think of a double as being able to hold double the amount of accuracy that a floating point could hold. What this kind of becomes is all these numbers are stored as in binary, and when I'm talking about bits, when I say 32 bits, it means that the number is held in binary and it can have up to 32 zeros and ones. And so because of that, if you were to think about an integer, the biggest integer that you could keep, well, let's think about, let's kind of analyze it before I tell you. So these are being held in 32 bits. That's why they call it like a 32-bit machine versus a 64-bit machine. And so these are going to be zeros and ones that are kind of in here. Okay? And the way we figure out what this number is in binary, you know, binary can only have zeros and ones. And 0 in binary could be something like this. 1 in binary could be this. And then 2 in binary would be this, and 3 in binary would be that. 4 would be like this. It kind of switches from 0 to 1, and then it increases to 1 the next digit, and then it repeats again. I'll do it a few more times, maybe you can pick up the pattern. Yeah, okay. And then from there goes to there. And if, you know, we can fill the zeros in front of these. And so on. And so if I said you can only have numbers that can be represented with 3 bits, that means that we would only be able to have these. And the biggest number that you could keep here would be, let's count it, 0, 1, 2, 3, 4, 5, 6, 7. You could only hold from 0 to 7. So you could only hold 8 values in here, okay? So if you want to keep both positive and negative numbers, you would only be able to hold a range from -3 to 3. Or maybe to 4. Let's see. It'll be -3, -2, -1, 0, 1, 2, 3, 2, 4, 6. Yeah, so to 4. Okay. Or you could keep them like 0, 1, 2, 3, 4, 5, 6, 7, right? So you could keep either of these. If you want to keep only positive numbers, then you could hold from 0 to 7. You want to keep some negative numbers, you could hold from -3 to 4. But here's the thing. What if I wanted to have number 5 stored? Well, then I have to use this number notation. But what if I wanted to have -5? Well, then I need more bits, right? So there's a limitation with integers on how big you can get. It turns out that number is around, actually, I might have it here. It's like 2.7 billion, but do I have it here? Nope, but I can Google it. It's actually something useful to know. It's about 2 point something billion. Int largest digit. Yeah, here we go. So I'll post it on Twitch. That's the biggest number. In fact, here's a description. Is the maximum positive value for a 32-bit signed binary integer. That is, how do you calculate that, by the way? Well, it's a power of 2. If you can think of here, this has 3. For a size of 3, we said is about, you can have a range of 8 digits because you count from 0. It turns out that 2 to the third, which is the number of digits we have, is equal to 8. So if you do 2 to the 32nd, you should get twice that number that is there. So it would be somewhere around 4 billion, 4.2 billion. But why can you only keep 2.1 billion instead of 4.2 billion? Because you're keeping both positive and negative numbers. So you slash it. Just like here, you slash by half the range, almost by half. The same applies there. So if you want to keep a number bigger than that, or you want to keep a number with decimals, that's when floats and doubles are going to come in useful. Float is still only 32-bit. So how can you keep more numbers and decimals, bigger numbers and decimals, if you're still using just 32 bits? Well, it turns out that it's doing some rounding, and in an overly simplified way, and I'm not going to test you on this. I mean, they will test you at some point on this, but not in 135, is what happens is, and you know, I'll have to refresh this myself later, but they split the 32 bits into, I think, 8, 1, and 23. Was that after 32? 24. No, yes. Yeah, no, yeah, that does after 32. Okay. Why, where is no chat in display? What? What do you mean? There is chat in display. You see the chat there. Is there like an issue with the chat? I don't know. Let me know if there's a problem. But anyways, so yeah, maybe it's because there's like a delay or something. So you saw text like before you saw me talking about it. That's the thing. I don't know. But anyways, cool. All right. So basically, what they do is they split the 32 bits into this fashion. They do 23 bits there, 8 bits there, and 1 bit here. This single bit, just like it would with integers, what ends up happening with integers is the first bit of the entire 32 bits is reserved for as a 1 or a 0 to represent whether the number is positive or negative. And then the other 31 bits are using this system here, which is why you get half of them. Okay? Over here, same thing. That one of the bits is for positive or negative. And then the next part is going to be, this number represents an scientific notation in the sense of like, do you guys remember in your math classes when they do something like 3.2 times 10 to the third power, 3.21, like that? That means this number is actually 1, 2, 3. So 1, 2, 3, yeah. This number is actually 3,210. Another example of that could be 3.21568 times 10 to the second power. In that case, what this number really is 321.568. Okay, so this is scientific notation from your math, physics classes, pretty much all the natural sciences and stuff and math classes that they use scientific notation. That's kind of what's happening here. This number here, this 8-bit number that you could have 8 bits of, is going to be your exponent, and then this, which has a name which slipped my mind, is going to be this part here. So you could say that here I'm going to store 321, and here I'm going to store 3, for example. Or I could say I'm storing here 3, 2, 1, 5, 6, 8, and here I'm storing 2. Mantra, I think? Mantis. I think this is called Mantis. Yeah, that name, I think it just came to my mind. I don't know. Here, let's see. Mantis, well, Mantissa. Somebody said Mantissa. Is that it? Control F, Mantis. Yeah, Mantissa. So Mantissa. Close enough. Not bad for remembering that. Here, I'll post this link actually. There's a picture there of kind of what I'm drawing. They have the sign, they have the exponent, and they have the mantissa. Yeah. So that's kind of what I was going. It gets a little bit more complicated than that, but for now, I think that's good enough for you to know. Now, where's the shortfall here? Okay, so you're still trying to put really big numbers, but your accuracy in terms of digits that are non-zero, and by non-zero I mean non-leading zeros or trailing zeros, is 23 digits, which means I could hold really big numbers here, bigger than 4.2 billion. In fact, how do I store 4.2? Let's store 5.1 billion here. 5.1 billion would be how many zeros? 12, I think. Let's go with 12 and see if that's right. So that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Cool. Okay. So now let's see what this number actually is by putting commas. Yeah. Okay. So that is a million. Did I do trillion? My dog says hi. Oh, she goes. All right. Yeah, I think I did trillion, guys. This is gonna be billions here, and then million, billion. Yeah, so I think I did 5.1 trillion. So here we go. We're going to like U.S. deficit levels at this point. But anyways, so 5.1 trillion. Okay, I can hold this number inside a floating point data type by having it have let's say 0, because it's a positive number. So I guess I've been putting 1 here, but I should have put 0 for the previous ones. In fact, let's do negative 5.1 billion. So that we do use 1 there. It's still bigger than we would have stored in the integer. So we would have negative 1 there. Then we would have had 12 inside of the exponent, and then the mantis would have been 5.1. And that's it. Yes, the random dog spawns. All right. And if we want to store it in binary, let's go ahead and do that. So that would be 12 in binary is going to be, well, let's look at our chart here. This would be 8, then 9, 10, 11, 12. Okay, so 12 would be 1100. 1100. And then 51 in binary. Google time. I don't feel like doing math. Decimal to binary calculator. Here we go. Enter decimal number 51. Convert. Okay. So that is 110011. That's beautiful because it's like symmetric, and I like symmetric stuff. Here, I'll post the link of it. You see, guys, Google is your friend. Like always, you have to learn how to Google things. Don't take it like I'm just like trying to be like, oh, Google it. I don't feel like teaching it. No, it's not that. I'm just saying you got to learn how to Google. Like Google is your friend. You can get a PhD with just knowing how to Google. So yeah, okay, all right. So Yeah, so here we go. Now we got ourselves the floating point representation. And as you can see, how many bits are we actually really using here? We're using 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're using 11, and we have up to 32. What went happening here is the real number, because we can't just shorten it, would be we have to make this 8 and this 23. So it would just be leading 0. So the real representation that you would see would be 4 zeros here, and then 1 1 0 0, and then here we have 1 1 0 0 1 1. That's 6. So 23 minus 6 is 17. I hope. We don't have space for 17 zeros there. Hold on. 1 2 3 4 5 6 7 8 9 10. Let's just imagine they all fit in there. 11 12 13 14 15 16 17. Let's just put them all together. They're all supposed to go in line, okay? In fact, yeah, you know what, let's not be lazy. If somebody watches this later, or at least watches the notes, they're going to be so confused if I don't put it like this. So let's take the second effort to put it in there, and let's hope that I did get 17 there, but there's supposed to be 17. Okay, there we go. Now this is exactly, if I was to analyze in assembly what is being stored in the register, you would see that this would be the exact binary representation. Of course, you don't do this because we're working in a high-level language. You would simply say float A equals 5.1 billion, which you would have to actually write out, I guess. I don't feel like writing it again. Let's just copy paste. Not billion, trillion. It's trillion right now. So you would write this. And of course, I don't know, we'll go over the declaration stuff in a second. Okay? Yeah. Welcome. You know, you took 218. You could probably clarify if I'm doing this right or wrong. But yeah. But anyways, yeah. So I called this the mantis, but it's pronounced called mantissa, or I hope it's pronounced mantissa. But yeah. So that's how you do floating points in not just C++, but in all of the most of the languages. And by the way, as you can see, that guy does have PTSD because he learns it in 218, and they go very deep. And there's more to it than this. This is the short hand waving simplified version of this. It gets way hardcore in 218, and I do believe I have to teach it in 219. So I'm gonna actually have to refresh it myself. So yeah. Okay. Now, what is the difference between that and double? The difference with double is it's 64-bit. So instead of having 32 bits, you have up to 64. For that, it's not just multiplying everything times 2. I do believe that the exponent goes from 8 to 12, and then the mantissa goes to like 56, something like that. That does not add to 64. Whatever 64 minus 13 is 51. So maybe this is 51, I think. Maybe. A quick Google would tell us otherwise, but just for now, know that it is bigger in terms of being able to have twice the accuracy per se. Okay? So, yeah. So, anyways, that's how you store decimals in C++ with floats and doubles. Okay? So, if you, or really big integers. But, I guess I didn't get to one point here. Here's the issue though. Yes, I can store really big numbers and really small numbers actually, because I could have be like 0.00000051. I could just have a negative here, and now I'm storing a really tiny number like 5.1 trillionth of a number. But there's a catch. You don't have the ability to store from 0 to 5.1 trillion every single number. Some numbers are going to get cut off, especially when you run out with a float. You got only 23 significant digits that you can keep. So if your number has more than that, if it's 5.1 trillion, but instead it's 5 trillion. 106 billion, 518 million. In fact, here, let's just write a number. So if your number you're storing is actually 5 trillion, 115 billion, 801,000,000, 256,111. Yeah, you can't store that because when you convert this number into binary, first of all, you're gonna need that many digits, and so you're gonna have a problem. In fact, could you keep maybe if you did only this amount? So if it was this much and then the rest were zeros, maybe. Because you're only gaining here space by having leading or trailing zeros. But by just using the by just having all significant digits, then you can't store it. So here is the binary equivalent of that number. Is let's see how many digits are here. 3, 6, 9, 12, 15, 18, 21, 22, 23. So okay, so I think this is about as accurate as you can get before it overflows or before you lose accuracy. This you could keep because when you turn into scientific notation, it's just 5.115801 times 10 to the 12th. You can keep that. But if any of these digits are not zeros, like if you have a 1 here or a 1 here, when you convert that number into binary, this at least this part, which is a significant part, the number of bits that you need is more than 20, what is it, 23 or 24? More than 23. And then you can't store it. So while you can store really big numbers, you can't store all of them. There's going to be some rounding that is happening. And it actually turns out that one of the things that I am hand-waving here is that the numbers here in scientific notation aren't kept like I am saying to you. So yes, I lied to you. They're kept with fractions. And because they're kept with fractions, it turns out there are some numbers that you can't even keep that are super small. Like I think you can't keep the number... it's one of the basic numbers from 1 to 10. You can't keep it as a whole number. You actually keep like 1.999999 instead of 2. And there was an correct question that I asked the first time I taught 135. I'll pull up the test and I'll show it to you next time. But yeah, don't go out and tell other people everything that I said here because this is not, like I said, you learn this in 218. But it turns out that a way to keep more accuracy is instead of translating the numbers directly like I'm doing here, what they do is they use fractions for that. So because of that, or whether or not you did it that method or this method, you can see how there's a limitation to the accuracy of the numbers you can keep. So there's no free lunch when it comes to using a double or a float, but you can definitely use it to maintain a certain level of accuracy that is, for most of the time, enough. Especially with a double, it's more than enough for what you're trying to do. If you're trying to do some super specific, like scientific calculation, like measuring the width of atoms or something like that, that's really tiny, or something really big, there are other data types that you can use that are not built in, but they're custom made to allow for that kind of high precision stuff at the cost of taking more space in the computer, which is okay because at that point you don't care about the space, you care about the accuracy. Like if you're trying to calculate the trajectory of a ship in space, where you actually don't want it to be off to a certain degree, because then that gets multiplied times trillions of miles, which a 0.001 error is going to represent so much distance that you just completely miss your target, like your planet. So that's my spiel about ints versus floats and doubles. So anyways, from there, the other data type that you do get a chance to have is a char, which stands for character. And the character is just a single character. So you can store ASCII characters or letters. And so let's go ahead and look at the Ascii table for that. Since not all of you may know what the Ascii table is. So there we go. This here is the Ascii table. Okay? And the Ascii table is, because remember, everything in a computer is stored in bits, in binary, zeros and ones. So we need to figure out a way of storing letters with bits, basically, with zeros and ones. With numbers, it's not that hard, because all you do is there's an easy conversion, which you learn in CP 100, to convert bits binary to decimal. And actually, I kind of show it to you right now, because I said you just take that number in binary, the number that it represents in binary, and you use 2 to that power. And then you can basically figure out pretty much what it is in decimal. So to do letters, what they ended up doing is they ended up connecting a specific number in binary to a specific letter. And all people around the world that were using computers had to sit down together and come on an agreement of what letter represents what number. And as you might assume, they didn't do anything weird. They did like A through Z. They didn't do like random letters in random order. They're not trying to make your life difficult. It's supposed to be something that is supposed to be adopted by the world, and it did get adopted. And so that's what the Ascii table is. The ASCII stands for American Standard Code for Information Interchange. And I just read that from there. I didn't know that by memory, but I could lie and say it. So, yeah, and somebody said hex. Don't get confused. We're not talking about hex right now. We're just talking about binary. Okay, hex, which stands for hexadecimal code, is not a numbering system. So, which uses base of 6 versus base of 2 for binary or base of 10 for decimal. Octagonal is 8, by the way. So, basically, let's look at this. The first representation in the ASCII table of a car, and these are all for a car data type, okay? So, is 0. The decimal representation of 0 it stands for null. Null is something that you put at the end of every string. And when we talk about strings and you see a null terminated string, that'll come back. So just remember that for now. Let's skip a couple of these. These are for like people when they were using a typewriter. Backspace, like backspace to delete something and so on. Not really relevant to us, except for maybe 10. 10 is a line feed character. When you press enter on your keyboard and it stores the line feed, you know, how does the computer know to store the line feed? And that is basically because it inserts the line feed character into the flow of text of binary code. When you do nline or when you do the \n, that's what's happening. It's throwing in this character in there, which tells the computer to print it on the next line. It's stored all as continuous blob of text, but the little line feed says show the remainder of the text on the next line and so on. From there, we actually go to the relevant stuff, which starts with 32, which is a space. So if you want to show a space between text, you use 32. Exclamation point is 33. You can see that numbers are here from 48 to 57. What this actually means is the character number, not the decimal number, but if you're trying to print out a number as text, that's what the ASCII code stands for that. Because the other ones are actual numbers. So here we're trying to use it to print characters, which are just text. From there, the alphabet starts, so you see a bunch of symbols, math symbols per se, and then at 65 you get the letters, the actual letters, from A through Z, and then you see them again from 97 to 122. That's because you need to keep both the uppercase and lowercase. There's no easy way of saying this is uppercase and this is lowercase. They're completely different characters because they're totally different symbols. Like you come from like an Asian language that doesn't use like a Roman alphabet or whatever, or Latin alphabet. I don't know what this is called. And you've never seen it in your life. You see this, and those are just symbols to you. Just like how if I was to see like Japanese, they all just look like symbols, right? That's because these are just symbols that are kept, and there's no association between uppercase and lowercase here, okay? So that's why you see them twice. And that's it. That's your ASCII table for you, okay? And so this is what has been agreed. This is very, very useful. Again, just Google it. Go to AsciiTable.com if you want to see it. Print it out. Put it in your wall when you're coding. If you you want to be like a hardcore, I don't know. So yeah, that is the Ascii table. It's interesting teaching 1 through 5. You gotta really go down to the bare bone basics. So yeah, Ascii table. And so that's what the car data type is for, is storing values from the Ascii table. Finally, we have string. String, however, is not a built-in data type. This is a big misconception in C++ at least. String is not built in. What is string? String is a sequence of 0 or more characters. If I can spell sequence. And now we know what characters are, because I just spent like 10 minutes going over that. Or at least it felt like 10 minutes. Enclosed in double quotes. You have seen strings before. When we said with the Hello World program, or when you're doing the Constitution and you put the little double quotes, that is considered a string actually. However, that string that you wrote, because you didn't actually use the word string in your assignment, what you did is actually called a literal. So let's actually define that because it's an important term. What is a literal value? A literal value is a fixed value that can be stored in the computer, basically. So it's a constant per se. If you think of math, it doesn't ever change. And so, in your case, when you were doing the assignment, or assignment 1, or when we did Hello World program, what we were using when we put the little quotes and everything and text is called the string literal, which is a series of characters enclosed in quotation marks. Okay? So when you said see out Hello World, or you're doing your assignment, you're doing the whole, well, not the whole, but like the piece of the Constitution that you got to do, this is a string literal. Later on, you'll see that you can also do integer literals, and you could actually also do floating point literals as well. So those are what you're basically, what we like to call hard coding, because you're putting it right on the code, specific values. Okay? Just a terminology term that you will hear a lot when they say it. Just use a literal. When somebody tells you to use a literal, it means just type it in manually like that. Okay? By the way, with a character, you wrap them in single quotes, not in double quotes. Like that. You're not actually going to go in there and put the numbers. You could do something like car and then put 64. And then if you look in the Ascii table, let's see what 64 is. Actually, it's the @ symbol. So the @ symbol for 64. So if you did car C gets 64, that's the same thing as doing C @ symbol. Okay? And we'll do examples of all of this in a second once we jump into coding. But anyways, the string data type, as I said, is not built in, which means that if you want to use it, in theory, you should include another preprocessor directive. We've learned IOStream. This is the second word we learned, is called string. Include string. You need to put this in because string isn't part of the language, so it gets added in. That's the reality. Or sorry, that's not the reality, but that's more of the ideal. However, most compilers will add it for you, so you never have to add it. However, I do want you to add it because I want you to I don't want you to become reliant on the compiler to the point that you don't know why it's happening. In theory, you should always have it in your assignment if you're dealing with strings. We didn't actually have it when we did in the first assignment, technically, but ideally you should, and because you shouldn't rely on the compiler, because if somebody decides they're not going to do it, then your program doesn't work anymore, right? So anyways, when you're using strings, in theory, you should include string, and that will give you all the string capabilities. Okay, let's see if I have anything else to say. All right. So from there, let's go ahead and jump into code, and I'll put some more definitions on actual in text. In fact, I can probably write faster there, and it's more readable, anyways. So let's just go in, because otherwise I'm gonna get bored to death here. We're in a coding class, so let's code. Let's get some water first. I should do a Caesar cipher assignment. I did. Last time I taught the class, so I don't want to give it again. So I don't think I did. I think I didn't. I think I didn't give that out again, as far as I know. But yes, the first time I taught 135, I did a Caesar cipher assignment. So yeah, it's kind of like easy thing to do, just to show people how to do switch statements. So oh, hold on, let me yeah, there we go. So we're gonna call this my second program .cpp, and actually maybe in a different folder. Should keep it organized, which means we need to go back one folder and then go there. Okay, it bothers me that it's spelled wrong, but here, let's do that in the terminal. Actually, it's good practice for you guys. My second program. If you want to rename something, you can use the move command, and voila, you get these fixed. Okay. I gotta at some point run that command, but not today. I guess I'll put this like this, and then I'll put this like this. Okay. So let's go ahead and do the most basic stuff that we have to do for all programs until we know any better, right? And that's going to be your include IOStream using namespace std int main. But hey, a little bit more is making sense now, because now you know what the int is in more detail. And we got return 0. By the way, this 0 right here, that 0 right there, yes, that one right there, is a literal. Yeah, it's an integer literal. So it's been there all this time, and you didn't know until now. Let's go ahead and do the other include string, because we are using them probably. All right, so there we go. Let's just test to make sure that everything is running. So let's just do hello world and line. By the way, that is a string literal, FYI. G++, my second program. It compiled, no errors because I see the next line. So ./a.out, and it says hello world. So that's funny. Okay, so all right. So okay. So now I'm gonna show you a couple of important things that you need to know, and that is what we're gonna actually declare some variables. Now, last time we talked about the identifier rules of what you can name variables. So now, like as a reminder, no numbers, no digits as the first character. What's okay is upper and lowercase letters for the first character or an underscore, and then for the second character and on, you can have letters, numbers, or underscores. But in general, you want to avoid using underscores because they're reserved for people who are smarter than us to deal with them. So just accept that fact. Okay. So anyways. Okay. So to declare a variable, we need to do what's known as a declaration. And a declaration is a statement that associates an identifier with a data object, function, or data type. In this case, the one we know is data type. Don't worry too much about the other ones. The goal is so that the programmer can refer to the item by name. Okay? So a declaration is basically associating a name to a variable. A variable is going to be, well, let's define that actually. So what is a variable? I know in math you know what a variable is, but let's kind of give it the computer science-y definition of that. And that is that it's actually a memory location. So somewhere in your memory, in your main memory, hopefully, is a little piece of a cell made up of transistors that is going to store the data that you give it. Okay, so a variable is a memory location with a name and the data type, because it needs to know it's always storing it as binary. It's always, so your variables are always being stored as binary. But as I said, that binary can represent a lot of things. Let's say you got all zeros in there. Okay, if it's a car, it's going to represent the first thing on the Ascii table, which is the null. If it's an integer, all zeros is going to represent probably a 0. If it's a floating point, that is going to represent 0 to the 0 power. So I think 0 as well. But let's switch it. Now let's say that it's holding 31 zeros and the last one's a 1. So 0, 0, 0, 0 and at the end a 1. In Ascii, let's check what the Ascii table for that is actually. So give it a second. Actual size. Oh, we got 22 viewers. Cool. That is start of heading. I don't know what that is. It's some random stuff. Okay. That's what it stores a car. With an integer, that stores a 1. With a floating point, however, that is going to be on the mantis, that last 1. And if it's using the system that I said, then it's going to be 1 to the 0 power. So I think it's still be 1. Dang. But anyways. Basically, in memory, you're just storing zeros and ones, and you're gonna give it the type in the computer so that it can translate those zeros and ones into whatever they actually represent. Okay. Yes, he does do that, but he has to name them with numbers otherwise. Because here's the thing: you cannot name two variables the same. They have to be. We talked about that the other day. So, anyways, a variable is a memory location with a name and a data type. And something important: the word variable indicates that it can vary, right? So its content can be changed during program execution. You can't change the contents in there. You can't change in C++ the type of it, but you can change the content. So you cannot change something that is storing cars into something that is storing integers, into something that is storing floats or strings and so on. It has to stay to the same type. Okay? So, what is the syntax? Remember syntax, rules of the language. So what is the syntax for variable declaration? Okay, so how do I declare a variable in C++? The way you do it is relatively simple. You need to put the data type first, and then the identifier that you're going to assign to it. Now, what is the data type? Let's say that we are going to create an integer, okay? So in that case, it's int for integer. And then if we're going with my IAS thing, it will be called cancer. And then from there, you put your semicolon at the end of every statement, as we talked about. And now you have associated in memory, somewhere in memory when I run this program, it's going to reserve a section of 32 bits in RAM. And that address, that's just an address somewhere in memory, is going to be accessible with the identifier that we have now named as cancer. Okay? And so if I want to store a number in there, I can go ahead and do an assignment for that. And the way that I do an assignment is using the assignment operator, which is the equal sign. So the assignment operator is the equal sign. Now I'm warning you, this is something that a lot of people, when they learn to program, have a hard time, because there's also an equal. The equal sign in math is not the same as the equal sign in programming. The equal sign in math indicates equivalence or equality, as in two things are equal, and there's no direction in that equality. Okay? If I say A is equal to B, that means that before I saw that line, I knew that A was and B had the same information. And after I saw that, A and B have the same information. It doesn't mean that I should copy the value of B into A or the value of A into B. It means that they already have the same data. Okay? That's what the equal symbol means in mathematics. And I believe also physics and those kind of applied sciences. In computer science, it does not. In computer science, in programming, the single equal sign is not equality. It's assignment. You assign information from the right side of the operator into the left side. And yes, when we talk about comparison, the equality that you think about in math is actually two equal symbols in C++, which, we'll get hopefully to that later today, and if not, next class. So yeah, that's very, very important to emphasize, because a lot of new programmers get those confused, and then it's just terrible. Not now, but once you get to like a if statement and you're trying to compare something by saying 1 equal to 2, and you say 1 equal 2, and bad things happen. Okay, so we put our assignment operator, which is what the equal stands for. So I'll even put it here. Equal is called a assignment operator, and we're going to assign an integer to that. So that's a whole number, positive or negative, no decimals, and we're going to put 9001. Okay, semicolon, because it's the end of the statement. What we have done now is we have assigned the value of 9001, which is a literal, into our variable cancer. If I was to go ahead now and print that out, I can. How do I do that? I use the same cout and extraction operator, but instead of putting a string here like, well, I can still put a string like, say, what is cancer, question mark. I can also put a variable in there. So I can go ahead and put cancer like that. And if I was to run this, what's going to happen is it's going to first print that string literal, and then it's going to print out the contents of the variable. Let's go ahead and run it and see if that's the case. It compiled. That's a good sign. And now we just ran it, and it says hello world, because at the top of the program we had a hello world, as you can see. Then we had a bunch of comments which get ignored by the compiler. And then we get to this variable declaration. Then we get into the variable assignment. And then we get to a print statement that goes and tells the computer, print out what is cancer, put a space there, and then print out the variable cancer, which has 9001 in it. And then an end line, which is why we go ahead and see that this is on the next line. Okay? So there you go. This is basically the most simple example of variable assignment in C++. Let's go ahead and practice a few more of those using the other data types. Okay? So first of all, let's go ahead and try to reassign the value to see if, in fact, actually, let's do something here. What happens if I comment out that line and I just run the program again? What do you guys think is going to print out to the screen? I have a declaration, but I never gave it any value. 0? Any other bets? So I could do a Twitch poll, but I think that's way too much. 9001, maybe no. Okay, all right. We run it and we get 0. So you were right, or were you? It turns out that that you were right this time, but not always. Because here's the thing: in this situation, I've declared a variable, but I never did something that is called initializing that variable. Initializing a variable spelled like that, means giving it an initial value. Okay? And if you don't do that, you have no guarantee of what will actually get printed out. In this case, the compiler is helping you because it sees you did something completely dumb. And so it's like, this guy's dumb. I'm going to initialize it for him to 0 so that he doesn't do bad things later on with it. It turns out that you're right. It would have a random number every time since it's not initialized. Absolutely correct. Because here's what happens. The OS is like, it's just chilling there. And then the program comes in and says like, yo, OS, I need an integer variable. So hook me up. And the OS is like, okay, I'll hook you up. And so it goes into imagine it's like a USPS box office worker. And he's like, I'll give you a PO box. And he just gives you the keys to a PO box, right? Here's the thing. That PO box, unless it's a brand new, which is not a brand new post office, more than likely somebody has used that PO box before there. So you go there, you open it, and guess what? The USPS Postal Service, they did not clean up the PO box. They just, the moment that the other person turns it in, they put it back in their key rack behind them, and then they can reassign it to somebody else. You open that PO box, and you find in there like a kilo of like cocaine or something. And then next thing you know, the ATF shows up, and you're in jail. You're like, oh my God, what happened? Well, it turns out that you never initialized your variable. And so when you were trying to show somebody what was in your PO box by opening it, you were at the mercy of whoever left it behind. So don't go to jail. Always initialize your variables before using them. All right. It is according to the acts of the ATF. So we don't want to piss off those people. So yes, I don't want them to shoot my dog. So yeah. Okay. So anyways, ultimately, the moral of the story is always initialize your variables, because while the compiler tries to help you out by initializing them for you, you cannot rely on that being always the case. And because of that, you always want to initialize them. Okay, so always initialize them. In fact, I do believe in the rubric, you might lose points if you don't in 135. So that's up to the TA to kind of be the judge of that. But if he does follow the rubric on like to the point, then I think he will deduct points for that. So yes. Okay, so that's my spiel about initializing variables. So what if you're lazy? What if you don't want to do 2 lines of code to declare and then initialize or assign? Then I have a solution for you. I can do int, let's say money. Let's say you're trying to see how much money you have. And let's say you have $1. So you can do that. And now you have combined 2 things at once. Variable declaration and variable assignment. Or in this case, a specific kind of assignment because you're initializing it. So this means at the same time the variable gets declared, you initialize it. This is like you going in the to the postal service and being like, I would like to get a PO box and please insert this letter into it immediately, which means clean it up and insert it. And they look at you, they take it, they go, they clean it up, and then they put your letter in there. So when you go to open it, your letter is there and no shady stuff. Okay, so that is a very convenient thing. It's just shorthand for doing what we did up here. I recommend you do this. However, it's not always possible to do this. It's not always possible to initialize immediately after you declare. If such is the case, then you're kind of stuck in the other way around with this. But yeah, so that's that. So when you can, you should. Okay, let's go ahead and let's say you want to store money in a better way with decimals. So let's go ahead and do a float. Real money. Let's call that one real money. A naming convention that I personally like to use for naming variables, if I have more than one word, remember, you can't do this when you declare a variable. You can't do like real space money. That's not a variable. Variables have to be all continuous, only A through Z, upper or lowercase or underscore. You could do this though, that's okay. And that's not underscore at the beginning, so you shouldn't have any problems. However, I personally don't like this because I don't like underscores. They're scary. So I like to put words together, but then capitalize the first letter of the second word and any follow-up word. So like, if I want to say real American money, I could do something like that. However, that's way too long of a variable name. So I think real money is as long as I'd get. Let's say that you want to create data and initialize it to you have $1.50. You can do that. And now you've declared $1.50. You can go ahead and print them out by saying, how much money do I have? Line feed. And then I can say money and then maybe real money. And here's the thing, I'm doing something intentional here by doing actually two things that one was actually semi-intentional and the other one was intentional. So let's try to compile this and see what happens. So we got an error. It says error, real money was not declared in the scope. Notice the keyword declare. Now you know what this keyword means. It means creating a variable. It says that you got a variable called real money and it was not declared and yet you are using it because it shows me the picture right there. It says you are using this money and you're like, wait a second, I declare real money. I am an owner of this $1.50. Where is my $1.50? And so you go here and, well, first of all, you can see the line number, line 25. I confirm, there we go, line 25. And you're like, I'm so confused, what is happening? Well, what is happening? Chat, tell me why my program isn't working. So you guys tell me. Case sensitive. Money needs to be capitalized. There we go. I'm proud of you guys. You are absolutely correct. Because the variables are case sensitive and C++ case sensitive, I have a uppercase M here and I don't have it here. And so because of that, it's not, I would say, it's not as noticeable. So yeah, that's why you got to be consistent with your variable names. But yes, when you do that, that would fix that. So we go ahead and we can go and reprint it out. And now it says, how much money do I have? 11.5, and then what is cancer? So first of all, I don't have $11. I have $1.50. So what happened here? Well, it turns out that I was printing money, which I have one here, and then I was printing 150. But I'm printing them back to back, as you can see. And so it's putting them together. So I found a way of making $1 and $1.50 add up to $11. So that's kind of nice. Profit, right? But not quite accurate. So if I want to space them out, I have to insert a space there. I can do that by doing this. I could also maybe declare a character called space and storing that as space. Like that. And then maybe I can just call space there. And so now if I run it again, I have separated the 1 and the 150 with the 1 space. Of course, if I wanted to do more than that, I could. Also, I don't like the fact that this is being printed on the same line. So let's go ahead and create a little tiny string called line feed. And this is overkill. Actually, I hope that's not a use variable name. That does seem like a use variable name. Oh, okay, we'll see. And in there, we're going to put just a line feed. And so now let's go ahead and call that here. Line feed. Let's call it my line feed. I'm scared that's going to conflict. Actually, if it conflicts, that'd be kind of good exercise to see that happen. And there we go. We've inserted a line feed. Now that's overkill because we could have used nline or just \n, but I'm showing you how you can put all these variables together. Okay? So yes, easy way of profiting. How do we feel about variable declaration? If you want the output to include the 0 in 1.5, how do you do that? Very, very good question. For that, you need a library called IOManIP, which we will talk about in a few days. And that allows you to specify when you're printing out a floating point or a double, how many digits you want after the 0. And you can also format it like if you want a left indent or right indent, or sorry, left justify or right justify, then you can do that. It's called IOManIP if you want to Google it ahead of time. It's something we'll cover within a few days. What did I do? I made it like full screen. Shoot. What's the Linux shortcut to get out of full screen? I don't know. Chat, help me out. Escape? Nope. Alt F4 would close the VM, so that wouldn't quite work. Yeah, I'll click away in a different monitor. Maybe that'll help. Yo, this is toxic. I've never seen this happen before. I click something. It's okay. I'll close it manually. There we go. That's funny. I don't know. It was a letter of the keyboard that I pressed. So I can experiment later and see which one I pressed. Like, I did something. I don't know. But anyways, if that happens to you, you can just go and right click on the well, I guess it's because I have multiple monitors that I can do that. If you don't, then you're screwed. Just you'd have to Google it on your phone or something to get out of it. But yes. Okay. Anyways, let's see. Did we declare all of the variables? We have a car, we have a string. Let's do a double. Let's do something nasty here. Maybe I can get this to happen. I can get the, yeah. So first of all, let me tell you something here. This line here of code, there's some stuff happening that I want to talk about, but we're not ready to talk about it yet. Technically, that 1.5 is being stored as a double, and then it's being coerced into a float. We will talk about coercion and casting later on, but there are some things happening there. In theory, if I want to make this 1.50 be actually be a double, I have to put the F in front like that. Okay, lowercase f. Then this is really a double, or sorry, a float. Oh, hold on. Let me yeah, okay. And also let me move this and cut off the edge. Okay, so yeah. G++, fade that out. Okay, so everything is still the same, but now it's actually a float. I was going to show you. I wanted to show you how they're not exactly the same if I do double 1.5, but we still need to learn about comparison. So we'll come back to that example. But how do you declare a double? You just put double, and then you say big money, because you can store big money there, even bigger, and then you can put like a really big number like that. Let's actually do that. Maybe we can get this to show something here. Let's see what happens. Yeah. Okay, this is good. I like this. All right, so let's see what happened here. I try to store this insanely huge literal into double, right? So I try to store what, I don't even know what this number is. It's like in the pentabillions or something. I don't even know. And as you can see, it got stored as 6.99321 e to this. There's no 6 here. There's no 9 here. That's fake news, right? Well, that's how it got stored. And there is that loss of precision that you get when you store too big of a number in a double or a float. Let's tone it down though and put it like that. Try it again. This time around it worked pretty good. It did round it up here. As you can see, it has a 6 here. But it worked. And I would say that it does have 14 digits in it. So I think that's pretty good. So at some point between the first one and the second one, in terms of size, it breaks. See? It's just completely wrong at that point. It's just like, who knows what's happening there. So let's see how many digits it takes to break. So that one breaks, and then if I take one more off, I think it's okay. Nope, it still breaks. And now it's okay. So that's about the limit, I'd say. So as you can see, there are limitations to the accuracy of the double point and floating point. This is the double too, so this is like the big one, right? And that doesn't look that big of a number, but it is. It's pretty big. So if you needed to put something bigger than this, Just when you gotta get into your custom data types, you'll learn those in 202. Okay, so that's variables for you. The other one that you should know is constants. So what is a constant? Let's kind of just scroll that. In fact, let's just comment all this out using these kind of comments. That's what these are convenient for, that massive amounts of commenting. So now if we were to run this, it should just be nothing, like it shouldn't print anything out. Oh, it prints hello world. Good enough. Okay, so let's talk about constants, okay? So constants are a little bit like variables and a little not like variables. They're still a memory location with a name, a data type, and the value, as variables are. However, unlike variables, as the name implies, the content cannot be changed during program execution. They are constant in their information that they hold. So when you declare a constant, you can never change it ever again. Why do that instead of a variable? Because sometimes it's useful and it protects you as a programmer. As you learn programming, you will find that there's a lot of built-in safeguards to avoid you from making mistakes that, while trivial, are easy to make. Constant is one of those safeguards. You declare a constant so that you don't accidentally change it. And if you try to change it, it's not even going to compile and it's going to give you an error. So what could be a good usage of a constant? Something that doesn't change. An example being a mathematical constant like pi. So suppose that I wanted to create a constant that held the value of pi. Constant pi, well, we got to give it a type. So the way you do it is the syntax. So syntax for constant declaration, which can be rewritten to constant decal, is going to be const, like that, the data type, the identifier, and then the value, like that. Here you can't split the declaration and the assignment because it has to be assigned at the same time it's declared. Otherwise, it doesn't work. With a variable you can, with a constant you cannot. And so let's go ahead and do that for pi. So const pi, again, const int pi, or not int actually, let's do a float, pi equals 3.141592. I think that's pi. I might be missing 2 pairs of digits there, but whatever. Close enough for our computations. Okay? So constant float pi equals 3.114 or whatever. Okay? So now let's just print it out. Let's see what's in it. So what's pi? What is in pi? Well, let me tell you what's in pi. 3.14152 or 9. Yeah, no, it's not an apple pie. It's a cancer pie. So, okay, a Raspberry Pi. As you can see, it works fine. However, whereas with a variable, I can change it at any time. If I try to do pi gets 4, notice the error that I'm going to get. Error, assignment of read-only variable pi, right there. I'm trying to assign the value of 4 to a read-only. And if you think of read-only files, they're files that you can only access but you can't change. That's kind of how a constant works. You can only access it but you can't change it. And so therein it fails. The F after means float, because if you don't put it, that is technically a double, which then gets changed into a float. That makes it into a float. We'll talk about it when we talk about coercion and casting as well. But yes. If I was to, however, do like a double fake pi, and then I copy the same information over, this one I can change after the fact into 4, and they would have no problems. Let me comment out the other one, and then I can do fake pi here, and you'll see that fake pi has a 4 on it. What is in pi? 4. Okay? That's because that one is not a constant. So, as you can see, anything that you could do with a constant, you could do with a normal variable. But the fact that you make it a constant is to protect you, the programmer, to not make mistakes. It's also, internally, it's faster as well. The compiler, when it sees a constant, it knows that it's always going to be that value. So it optimizes the code to take advantage of that fact. And will make your code faster, essentially. And so you do want to use constants for that purpose as well, to make your code a little bit faster. So if you need some piece of data that is always going to be the same value, use a constant. You can also just use a literal. If you can hard code the number. But the thing is, if you're using that in a lot of different spots, and you need to change it later on, you got to change it in all individual spots. So if you make a value, it overwrites the constant value? No, they have different names in here. So because they have different names, they're different variables. One of them is a constant and the other one is not. I'm only modifying the one that's not a constant. There is no way that you can modify a constant without getting into some nasty stuff that you might learn in 202. But yeah. So if you try to override a constant value, it will not compile as shown. Okay? Hopefully that clarified that. If not, let me know with a follow-up. Okay, cool. All right, great. All right, so the semantics of this, as I said, is allocate the memory, stores memory, and then marks the contents as unchangeable. Then I have a little spiel about the advantage of using name constants. Avoid errors, makes program easier to read and understand. Then I have suggestions for variable names. Choose meaningful names that relate to your program. I think I already said that. Use a naming convention where you always stick with lowercase in the beginning, and like I said, you can go with uppercase. It's not very good practice to use uppercase for your variable names like you would in English. Also, let's talk about documentation for a second. This is almost self-documented because of the name. However, if you were to document your code for your assignment, you can put a comment saying here, this variable holds the value, the mathematical value of pi. That would be a meaningful explanation of a variable. Another one, we used cancer, right, earlier. We said cancer 5, okay? Let's say this, you don't have to put the words variable every single time. You can also say holds how many patients have cancer. You know, you can say something like that. You want to document what the variable represents because it may not always be obvious, okay? Because maybe this was actually hold how many people have the horoscope of cancer. You know, that could also be what it means. Like, we don't know, right? So you need to make sure you document your variables by providing a brief description of every major variable and making the name meaningful. If this variable is supposed to hold the number of people enrolled in the class and it's called cancer, first of all, you're insulting your class, and 2, it's not meaningful at all. So you want to make sure you make your variables meaningful names, okay? Also, there are 2 mentalities with variables and where to declare them. One of them is you want to declare them at the beginning of your program before you do anything else, and then you start writing code. So like I would just throw all my declarations at the top of the main function right here and then work with them. That's one mentality. The other mentality is you want to declare them as close to this places where you're going to use them. Both mentalities have a validity to them. However, some languages like C force you to declare everything at the beginning. In C++, there's no limitation to that. I don't even know what the rubric says about that, but in my opinion, I would leave that up to you. But the biggest thing, be consistent. If you stick with one way or the other, but don't go half and half. You want to be consistent with this. It's like if you're writing a paper on the MLA format, don't randomly in the middle of it switch like Chicago or something. You know, you stick with MLA or you stick with Chicago, that kind of thing. You don't just like pick and choose which format to go with each thing. Yes. What else did I want to say? There was one thing I wanted to say, but I forgot. Oh, well, that's okay. It's probably not important. So, okay. The same applies for naming constants as naming variables, okay? Then I already talked about assignments. However, I do want to point out that assignments are not just limited to literals. I could do the following. I could say fake pi gets pi. And maybe give this something else at first. Let's give it like a 22. What's going to happen here, and let's go ahead and print this twice, is the first time it's going to print 22. The second time it should print 3.14. We have an error. We forgot a semicolon on line 40. Well, it says 47, but the error is really in line 44. See? The fact that I've seen that error tons of times helps me to decide what's wrong. All right, we got another error. We have redecoration of cancer. We declare cancer multiple times. There it is. That's cancer. All right, there we go. Okay. As you can see, another error that you can detect. So, yes. Okay. So, what is in pi? 22. What is in pi? 3.14. Notice that this is that first print and this is second print. As you can see here, I am reassigning a different value to fake pi. You can do that. And yes, it is multiplying. You can do that in your program, and that's actually a very powerful thing. What you cannot do is you can't do it the other way. You can't change a constant, but you can definitely use that constant to change other variables with it. And so the way this works, it goes from right to left. So for example, what if I did this? Actually, that won't compile, but what if I did it this way? Yeah, let's do it this way, like that. Okay? So here I'm saying, assign the value of pi into cancer, and then assign the value of cancer into fake pi. Okay? Now this is a good one right here, because pi has 3.14, cancer has 5, and fake pi has 22. Okay? Oh. Ooh. Yikes. Thank you, guys. Yeah. Sorry about that. Okay. See, the code is growing in size. So, yes. Okay, like that. So you didn't see it before then either, I guess. Oh, it's because I scrolled down for the cancer part. Yeah, that's right. It's okay. Let's go. All right, so let's do this one now. All right? Yeah. So, okay. So here we got pi, which is a constant flow, which has 3.14. We have cancer, which has 5, and double fake pi, which has 22. Okay? So we're saying print out fake pi, which should print out 22. In fact, let's print out all three values at once. Let's make it nice. We'll say fake pi, colon, space, and then we'll have the value fake pi. Then we'll have a space, and then we will have pi. And then we will print out pi. And then we'll have a space and we'll print out cancer. And then we will print out cancer like that. Okay? And let's go. Oh, and yeah. And let's do the same thing down here after our assignment. Okay? So, what do you guys think? Let's go ahead and let's try and run a poll. Manage poll. Should final exam be comprehensive? That's from 302. New poll. Okay. What is the value of fake pi, and cancer? Is there a way that people can type in answers? Dang, there's no easy way. Well, okay, let me ask you. That's okay. You guys just screw the poll. What do you guys think is going to be in fake pi at the end of this? Is it gonna have 3.14? I guess I'll run the poll. 92? Is it gonna have 5? Is it gonna have 22? Or is it not gonna have anything? There we go. I think you guys can see the poll. Can you guys see the poll? View results. I ran the poll, but no one's voting. Oh, there we go. Now we see voting. That's kind of cool to watch it, how it fluctuates. Let me see if I can show that. I like it. I like it. There's a big debate going on what's going to be in it. Oh, look at that. It's like a turn, you know. It's like the last minute election change, you know, it's fluctuating. Only 8 people are voting though. That's pretty sad. And it's a draw. It's a draw apparently. So 50-50. Okay, what you guys seem to have agreed upon though is that it will definitely not have 5, right? You said it will not have 5. Like you at least unanimously agreed that it should not have a 5 in it. That's good. That's good. All right, let's go ahead and try it out. All right. It compiles, it runs, and let's see, fake pi first has a 22 and then has a 3 in it. So guess what? It was none of them. So it was a curved ball because I mistyped 5 into 3, but it's okay. So let's actually understand why this happened. All right? So let's see. Let's see what happens here, okay? First, you know, the values RSS should be, you know, pi has a 3.14, cancer has 5, and fake pi has 22, right? But then, when we do the assignment, we are taking the value of pi, which is 3.14, and we are copying it into cancer, which gives cancer from 5 to 3. Now, why is cancer not 3.14? Here's why. I didn't expect you to get this right because we haven't talked about this, but cancer is an integer. It can only store whole numbers. And when you feed it a floating point value, you feed it with a decimal, it doesn't understand what these decimal things are. So all it does is it drops the decimal part. It doesn't round, by the way. It just drops it. It just takes the whole part, the whole number part, and keeps it. So if this was 3.14, as it is, it changes it to 3. If this was 3.99, it would still change it into 3 because it just chops off the decimals and it's like, I don't know your decimal stuff. I'm just taking my whole number because that's what I know, and dumps the rest. So it keeps the 3, okay? It keeps the 3. And so from there, because you're going from right to left, it takes that 3 and assigns it into fake pi. Now, fake pi is capable of holding decimals. I believe it's a double, right? Yeah, it's a double. So it is capable of holding decimals. However, here's the thing. Because it went through the integer, it got switched to it got switched from 3.14 to 3. So even though fake pi can hold decimals, all it's getting is a 3 from cancer. And that's why fake pi only has a 3 in it and not 3.14. So that was a little evil, but yeah, why not? So hopefully this is a learning experience, and now you will remember that. All right. So cool. It's a cool one, right? All right. Let's see what else. That concludes chapter 2, I think. Let me see. Important programming facts to remember. The data type of the expression should match the data type of the variable. Oh, well, yeah. That's what happened right now, actually. If not the data type, result will be coerced. Yeah, so basically the reminder is actually what we just happened. That's almost like a cool coincidence. Order matters. Your order matters. Yeah, it does. It goes from top to bottom and it goes from right to left, okay? As you can see, it chains things by having it go that way, and it's very important. Okay, so now chapter 3/homework. Let's go ahead and pop the homework open, because for the homework, you do need some of chapter 3. You need to have the ability to do math, because I believe you're computing stuff. So let me pop open assignment 2. That one was made, as I said, by Dolly. And I do believe it has things with like sine and cosine or something. So Let's just give it a second. All right, let's close this poll, by the way. CS135. Still debating on that one assignment that is not posted yet, if I will have it or not. Okay, assignment 2. So there's assignment 2, all right? It says, purpose, become familiar with the basic C++ syntax, input, output, and simple arithmetic operations. So you need the arithmetics. You can read the lore. Dolly and I agreed on the space theme, Duna. I can't remember the book. So I think in one of my assignments I did it. But then for the rest of it, I just kind of winged it. So it's not very following of our theme. But that was the original goal of all assignments, was supposed to be following that theme. I'm not sure how much Twitter matches that theme, but that's why I made the alternative with NASA, because it's space themed. So, yeah. Okay, anyways. Welcome to planet Arrakis, otherwise known as Dune. One of the strange creatures that lives on the planet is a huge sandworm. Write a program to calculate the radius of a sandworm based on 2 measurements taken by a drone. Oh, snap. There's like trigonometry and math involved. And then you get a bunch of formulas. And then you get more formulas. And then, but she's nice enough to tell you that you will need to use the sin function, which is in the CMATH library. So let's go ahead and do that now. Let's go ahead and use the math library and explore how to use square root, sine, and other ones, okay? And from there, we'll go back to arithmetic stuff. And hopefully we cover that, okay? So let's go ahead and comment out this stuff. Or maybe let's go to another file at this point. This has gotten kind of big, and it's kind of hard to keep track of. Their program.cpp. Yeah, you'll miss 302 too once you get to like compilers and all the hardcore classes. So it's not over getting hard. IO stream includes string. So now we're going to include a new library called CMATH. That contains a bunch of useful mathematical formulas that can be useful in calculating math stuff. Damn it, autocomplete is just not being cooperative. CMATH. Okay, so let me show you a couple of these. So we haven't talked about functions, and I did have a discussion with Dolly about this because why do we have single string? Just in case that we use strings and to protect ourselves. I just threw it there. Why not? But anyway, so I had a discussion with Dolly about this because I was like, yeah, we haven't taught functions, so are you sure we should talk about functions this way? But she said it's okay, and that people don't have issues with that. And in a way, we do kind of talk about things that we don't. We do a lot of hand weaving anyway, so I guess we should be okay. So while we have like at least 3 days completely on functions and how they work and how to create them, etc. Right now, you're going to get the 5-second version of that. Okay? So a function, as the name implies in mathematics, a function, when you think of f of x is equal to x squared, this, for example, will be a function that squares the input. The f of x means take the value of x and perform certain mathematical operations on it. If I said f of x is equal to x plus 5 minus 2x plus 3x squared, that's a formula, right? So that means take x and do all these math equations to it. So add 4, subtract, blah, 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 and then give you back a value. In math, that's what a function is, okay? That's math. This is not C++, this is math, okay? F of x. When you think of a slope, y equals mx plus b, you could also write that as f of x is equal to mx plus b as well, okay? So in math, you put this sort of notation where you have f, you put parentheses, and you put x. You actually do the same thing in C++. If you're using a function, like for example, sine, or let's use square root function, you would do it like this. you will do SQRT for square root. That's just a name. Instead of F, this is the name they gave it. Again, identifiers can be anything, letters, uppercase, lowercase, no digits as the first one. Digits can go after. Underscores are okay anywhere. And so, for example, I could do square root of 25 like this. And this will basically call a function in the CMATH library that is basically f of x is equal to square root of x, basically. Okay? And so this should give me back 5. If my calculations are correct, you're about to see some serious math. Oh, gotta compile it with the new name of the program. So there we go. CMATH 5. There we go. And voila, this is how you call functions, or at least library functions. Okay. Other ones that you could use, and you seem to use in the assignment, it says you use the power function. So how do you use the power function? Power function is basically exponents. And if I recall, this is as much as a review for you as it is for me, I believe the first one's the base, and the second one, well, Visual Code is very nice. It tells me right here when an autocomplete. It says return a to the x. Return x to the y power. So the first parameter is the base, and the second one's the exponent. So if I do 5 comma 2, it should be 5 squared. So that should give me 25. And it does. Cool. Let's do one more. 3 cubed. No, let's do 3 to the 10th. That sounds scary. Let's see how big that number is. 59. That's not as big as I thought. 59,000. So that means 3 times 3 times 3, 10 times. Okay? Cool. Another thing is you can chain these together. So I could do square root of 25 comma 2 like that, and then put the pow out there. So this is going to kind of work its way from right to left, but within functions in math, when you have a function within a function, so when you have something like f of x, you need to first compute the inner function before you can compute the outer function. The same applies here. Well, I'm looking at the thing. She has a thing about sin, square root, and pow, so I think you are using them. That's why. How do you get the pop-up telling you how to use pow? I just installed Visual Code, and then I installed the libraries that it comes with. Extensions, this one's C++, C++ compiler, C++ project guide, IntelliSense, and so on. So yeah, just make sure you have those, and then you should have the autocomplete happen. You can search extensions here and then install them. No, you don't need the latex one though. That's for something else. Yeah, I should have said this earlier. I'm glad you asked it, because it's actually pretty useful, pretty convenient. Like I didn't remember how POW worked. Now I do, because it told me. So yeah, you definitely want to set that up. It's pretty useful. The only thing it said is alpha 2. I don't know. I see here stuff about sine and cosine, and so that's why I'm showing you guys these. If not, they're good to know anyways. So, okay. So anyways, here I have things nested. So we get 25. That's because first we do the square root of 25, which is 5, and then we square it back again to 25. And I could chain this and do like back and forth like 1,000 times, okay? So I just want you to know you can nest things. In fact, let's do one more time. Let's do square root of this. And you got to make sure you get your parentheses right. That gets you 5, okay? Because first, we work our way from the inside out, just like we would in math. This gets you 5, and I think math is a requirement for this class. This gets you 5, then this squares it to 25, and then the square root gets it back to 5, okay? You might have to stare at that line for a few times till you get familiar with it, okay? Finally, let's do sine, trigonometry. Oh boy. What is the sine of 90? I think that's 1 or 0, either or. If one of them is 0, then the other one would be 1 for cosine. So one of those is going to give me 0, one of those is going to give me 1, if I remember my trig. And by trig, I mean I'm triggered. Yeah, damn it. Why? Okay, let's try that. Oh, okay, so it's a 0. So the sine wave and the cosine wave, it goes like that, and I guess I got it halfway in the wave. I don't know. I gotta see a picture of the cosine wave and sine wave. All right, so the sine wave starts at 0, then it goes to the top and then comes back down. Okay, yeah, all right, that makes sense. And this is probably in radians. Or degrees, I'm not sure actually. But anyways, that's what you call sine and cosine, okay? So that's the ones that you need to do for the assignment, basically. Is there any other mathematical CMATH library functions that you need? I don't think so. So here are the formulas. You got you got division. Yeah, okay, so I think those are the only ones that you need. Sine. However, you still need to figure out how to do addition, subtraction, multiplication, and division. So let's just hit those really hard, really fast, and then continue them next time, I suppose, in the beginning of the next class, okay? So, all right. You've learned how to declare variables, so let's go ahead and declare 2 variables, 2 integers, int a and int b. And a is going to have 5, and b is going to have 3, okay? How do you do math in C++? Okay. Remember back in math, the term operator and operand, okay? Operator is something like plus, minus, subtraction, multiplication, division, right? There are unary operators, there's binary operators, and so on. So, for example, addition is a binary operation because the syntax behind it is operand, operator, operand, right? In this case, the operand is a number in both sides, and in the middle is the operator, which is a plus sign. Okay? Oh, thank you. Yeah, so, all right. And so basically, the operand and operator, okay? So, for example, if I want to do 4 plus 2 in math, 4 and 2 are my operands, and plus is my operator. If I do 4 minus 2, that means that 4 and 2 are yet again my operands, and the minus is the operator. On the other hand, if I have something like -4, that means negative number. That can be considered as operator operand, right? It's a unary operator because there's only one operand. Whereas a binary operator, there's 2 operands. Okay? That's math 101 for you, or math 98, whatever that is. Okay? And so if I want to do in C++ this way, the same rules apply. Addition is an operator and subtraction is an operand. Wait, what? What? Sorry. Addition and subtraction are operators and the numbers are the operands. So, suppose that I want to add 5 plus 3. I will do it like you think. 5 plus b. This is algebra, you know. Add those together should give me 8. If I run this program, you will see that I get 8. Let's go ahead and comment out the rest of the stuff so that we don't clutter the terminal with scary math. Okay, 8. All right. That's good. I can also create a variable c and simply do c equals a plus b. In this case, I am using my assignment operator and I am assigning the result of the addition of a plus b. And then I can simply do c out c. And that should also give me 8. As is the case. Furthermore, I can also change this to say c times b, or sorry, a times b. That's going to give me 15 because I'm doing 5 times 3. Let's do division and see what happens with division. 1. It's saying that 5 divided by 3 is 1. Is that true? I don't think so, because 5 divided by 3 is actually more than 1. It's 1.666 repeating. Okay? However, because C is an integer, what is happening is the same thing that happened with our cancer example. There is coercion happening where it chops off the yes, this is assignment 2. There's coercion where it chops off the decimal part of it and just keeps the integer part. So even though 1.6 you think should be rounded up to 2, it's simply kept just as 1. So that's why when you do division, this is known as integer division. If you want to be able to keep accuracy there and actually keep it as a double or a float, then you will do that. But first, let's just go ahead and do the division directly here and see what happens. If I do the division there, I'm still getting an integer, right? So it doesn't matter where I'm doing it. What I have to do to maintain it is one or both of these variables have to be something that can store a decimal. And that's going to tell the computer that the resulting value of this division should be kept as a decimal and not rounded out. As you can see now, I get 1.666 because I went ahead and changed B to a double, and that kept it. However, if I set C out C here, you will see that I still get an integer of 1. Or, ooh, what? I didn't save it, sorry. I still get an integer of 1. That's because C is an integer. So even though over here it's all good, then it gets coerced back down to a 1 here. It gets the decimal dropped off. So in that case, I'd have to change this also into a double. And now I will actually be able to keep the 1.66 in there. So I need both of these to be doubles if I wanted to do it this way. I can also do assignment to the same variable. So I could do something like this. And I don't even need C in there. In this case, it's going to take A and B, which is 5 divided by 3, compute that division, and then store that value back into B. So it's going to overwrite the 3 with the 1.666. This is okay because we're going from right to left, and it keeps it in the temporary place in memory before overwriting it, so you don't have problems where it's trying to divide itself or something weird, as you can see there. Okay, so that's how you basically do arithmetic operations. There's nothing else fancy about that. What would happen if you changed just C as a double but kept A and B as integers? I did that. So I can do it again if you'd like. It basically will we'll keep it as an integer. We'll keep it as a 1. So if I do this, you're saying if I do this and then I do int C, and then I do A divided by B, that will be stored as a 1. Because even though the division gives you 1.666, it gets chopped off. Okay? Double x 0.00. That merely means that I'm assigning the value of 0 to it. So if I want to say double x gets 0, that's the same thing as saying double x gets 0.0. Both are the same thing. I guess they chose to put the second one to help sort of indicate that it's a double. X equals sin y. That means that x, which is a double, is going to store the result of our sign computation. So instead of printing it out, I'm storing it there. So it's going to store the resulting value. So if I do something like sine of 0, which we said was 1, then this should print out 1. Damn it! I have two doubles. Oh, here we go. So just comment one of them out. 0. Damn it, not 1, 0. But anyways, that's because sine of 0 is equal to 0. So that's saying compute the value of sine to whatever it is, and then store it in X. Now here I'm putting a 0, but I could just put A, and that's going to compute the value of sign there and store that value, which is some tiny number, not that tiny actually, but it's a negative number, close to 1, into X. So that's what's happening there. Okay? Questions? In the meantime, for your reference, I'm going to put in here some useful values. In the last, we have 5 minutes left, so. So integers or integrals, we know there's a whole numbers. There are also other data types which we didn't talk about, such as short, int, long, and boolean. We'll talk about this next time. As I said, the biggest value for integer and smallest one is around 2.1 billion in both sides, positive and negative. Floating points are real numbers, as we talked about. And then the biggest and smallest numbers that you can keep, even though they're not accurate, they don't keep the entire range, are these. So I'll just throw that in there. Like I said, we will pick up chapter 3 where we left off, and we can do more practice on these. I still need to show you, I show you addition, multiplication, division, subtraction. Those all work the same. There's also modulus, which I will talk about next time because they have 3 minutes and I don't want to rush it. So you should be able to finish assignment 2 now. But if not, then you can wait until tomorrow. But try it out first. I think it covers just about everything. Will assignment 3 still be due this Sunday? It depends on if we finish if statements on class tomorrow. If we don't, then it'll be extended a few days. Yes, there is a lecture tomorrow. The class runs Monday to Friday for 2 hours. That's what I'm required to do. So yeah, assignment 3 is the weave quiz. So yeah. Yes. So tomorrow class at 7, and then Monday we will change the time to whatever the poll results were. So tomorrow will be the last day that class will be at 7, and then it will be reevaluated based on what you guys said. Okay, and that way we have the weekend to adjust. Because if we said classes in the morning, then we have class now and then literally 12 hours later. So we have that readjust in time. All right. So yes, just keep going to 7 until I post otherwise. I'll make a Canvas announcement on the big thing. So if I'm assuming people will want the time change, but we'll find out. I kind of want to change. It's kind of late, and I haven't even eaten. I woke up and taught, and now I gotta go eat. All right. Any more questions? Anything? We good? The dab needs to be more intense. I don't know how to do a more intense dab. Oh, damn, that doesn't work. Let me switch. Sorry. All right then. Cool. I'm on Discord, so yeah. As you do the assignment, if you have problems, then just post questions. Don't forget to do the lockdown browser syllabus testing. Some people had issues with that one Droid app, and they posted a different one that seems to be working better. So if you haven't done that, you need to do that ASAP, because I think it's the deadline for it is like today or tomorrow or Sunday or something. So just do it ASAP. It should take a very short time. It's a little quiz. It's like 3 questions or 7 questions, and they're like, what percentage of the class is the homework or something. And the academic misconduct, that's a 8-minute video. I did answer the Discord, the 74. So I said you wanna in this case you will go over that because of the size of the text, which means that yes, you can go over in your code itself as well in those lines. Don't do the rest. Don't do the other lines like that, but those lines you can. That way you don't have to do that many cout statements. If you want to, you can also split it, but you don't have to. So yeah, the deadline is midnight tonight. I think so too. So get that. That's priority 1. Do those quizzes like now. Okay? There's no extensions. If you miss it, you miss it, and that's very important that you get that tested, that working, because that's how we will take the test. I don't want to have problems in the test. And if you do, then it's on you because you never did the quiz. So, you don't want to get in that situation. It's censored to you, I think. That's funny. Is it Endel or Endel with a space? It doesn't matter. Both work. Both work. As you can see, when I was doing code, like sometimes I put spaces and sometimes I did not. It doesn't matter. I put the spaces because it makes it nicer to see, like here. But as you can see here, I'm doing spaces. Here, no spaces. The spaces don't matter. You can have them or you cannot have them. Actually, for this it's okay, but for this, that could cause problems. So I think there you do want to have a space. But when it's divisions, when it's an operator, spaces are okay. When it's this, you might run into some problems. I don't know. I think this will work though. Yeah, okay. But that looks nasty. But yeah, so you could compress this whole thing. It's just painful to read. You know, you also want to make your code readable. So, okay. All right then. Get the quiz done. So I'll see you guys tomorrow until further notice. Bye.